Problem 16. From the figure, we can see that there are 7 unit cubes, so the volume should be 7. And there are 6 cubes that are facing outside. One center cube is completely inside. We can't see any surface. So for the 6 cubes, the surfaces that can be seen for each of the cube is 5. So the surface area will be 6 multiplied 5 equals 30 square units. Therefore, their ratio should be 7 to 30. The answer is D. Problem 17. Let's assume the length of the rectangle is L, and its area can be represented by S equals L multiply its width, which is its perimeter 50, divided by 2 and subtract L. This equals 25 L subtract L squared. And we can further write this into 25 over 2 square subtract L subtract 25 over 2 parentheses square. So now let's look at this part. Because L subtract 25 over 2 square, because L is an integer here, and then the square has to be larger than 0. So in this case, if we want S to be the maximum, then we should make this square to be as small as possible. Therefore, L should be closer to 25 over 2 as close as possible. Therefore, in this case, we can get that L should be 12. Similarly, if we would like the S to be the smallest, its minimum value, we can get that this square should be as large as possible, so we can make the result here to be as small as possible. So in that case, L, this is when the area is max, this is when the area is minimum. L minimum should be 24. Now let's substitute L max and L min to the formula here. We can get when the area is max, subtract when the area is minimum, we get it's 25 over 2 square, subtract L max, subtract 25 over 2 square, subtract 25 over 2 square, plus L min, subtract 25 over 2 square. Now we can substitute L min and L max into this formula here. We will get this is L minimum minus 25 over 2, which is 24, minus 25 over 2 square, subtract L max, subtract 25 over 2, which is 12, subtract 25 over 2 square. And we simplify this, we can get this equals 529 over 4 subtract 1 over 4, which equals 132. Therefore, the answer is D. Problem 18. We know that the radius of the small circle is 10 meters and the radius of the larger circle is 20 meters. And the route is from A to here, it's a quarter of the larger circle, which is 1/4 of 2 pi r. And then these three straight lines will add up to 2r. And then these two will add up to half of the small circle. That is 1/2 2 pi r. So we substitute capital and smaller case r into this. We can get that it's 1/2 pi multiplied 20 plus 40 plus pi multiplied 10, and that is 20 pi plus 40. Therefore, the answer is E. Problem 19. We can say that if the points are 1 unit apart, for each of the 8 units, for each of the 8 points, we have 8 choices, and then we can choose the other point. We have 2 choices for the neighboring points. Like, for example, if we choose this point first, then we can choose either this point or this point as its neighboring point. So that's 2 choices. And then because the order of the 2 points we chose doesn't matter, so this should be divided by 2. And so that's 8 total choices where the 2 points are 1 unit apart. And then for the total number of choices, we have 8 multiplied 7 divided by 2, and that is 28. So the probability should be 8 over 28, and that's 2 over 7. The answer is B. Problem 20. Because 2/3 of the boys, we use B for the number of boys, equals 3/4 of the girls. So we get this equation, and then we simplify it. We can get 8 multiplied number of boys equals 9 multiplied number of girls. Therefore, the minimum possible number for the boys should be 9, and minimum possible number for the girls should be 8 to make this equation satisfy. So the total students should be B plus G equals 17. The answer is B.